In the previous slide, we introduced you about the voltage difference and the device who can produce the voltage difference. For example, like the battery and generator. And what happens behind is that this device will provide you the voltage electric potential energy there. And when you connect the wires to the voltage device, then the electric potential energy will be converted to the kinetic energy of the electrons. So electron will start to move. And where are all these electrons from? They are the particles, the conduction particles in the metal. Yeah? So the energy will be released and they become the kinetic energy. So therefore, you will produce a movement of the charge, and which is the electric current. So the electric current is generated when you connect it to a device, provide a voltage difference, or you can try to using the language, the electrical pressure difference, which is the example when you study about how the water flow in the pipe. So electric current actually can be defined in terms of the flow of electric charge. So by convention, we simply just assume it is the movement of the positive charge. So this is just by convention. And in the metal, the particles, the charged particle moving are the so-called conduction electron. And in the insulator, the particle move is the positive and negative ions, which is much harder for them to move. That's the reason conductor is a material people use to make the wire, because the electricity can be conducted smoothly. And the unit, SI unit for the electric current is amperes. So amperes is 1 coulomb of the charge per second. So this is a very big numbers. So in your daily life, you will seldom see 1 amperes. So do you remember in the lab last week we conduct? So the current you measure are at the unit milliamperes, which is 10 to negative 3. So please keep this word in mind, is that amperes is a very big current, and normally you will not see that in your daily life. And the second illusion people will have is that they say the electric current is the flow of the electric charge, but it is not one single electron moving from the higher electric potential all the way to the end with lower electric potential. Instead, it is a bunch of the conduction electrons interacting with each other. So for example, the first electron will start to move and hit the second one, and they will pass all the energy to the second electron, and second electron move and hit the third one and continue. So this is a concept of the electric current. So therefore, here I say that the actual speed of electrons is slow in the wire. It is just less than 1 centimeter per second. But please think about that. Electron is a very tiny object. Even 1 centimeter is a very long distance for them. But the speed is definitely much slower than you thought. But the signal transmitted through the electrons is near the speed of light. And that is related to the picture I just mentioned. It is not one single electron moving from very beginning to the end. It is a bunch of particles interacting with each other. It is the signal transmitted. So let me give you a sense of feeling that the magnitude of the electric current in our daily life. So for example, your body can feel 1 milliamperes, and that is already the unit we use. And if you have 5 milliampere, you already feel painful already. You see, 5 milliamperes, 0.005. So this reason I say that if you have 1 ampere, it is basically impossible in daily life. So please make sure you have this kind of common sense after the lecture today. So you know that, for example, if you have only up to 0.15 amperes, the muscle control will be lost. So you can see now how serious it is. So now let's have another conceptual quiz. And the answer is A. So electric current is the flow of electric charge. And it is not intrinsically stored in the battery, okay? The battery only provides voltage difference. And it is the electrons within the wire move and flow. So electric current has two different kind of categories. One is the DC current and the second one is AC current. What does that mean? So DC current is the so-called direct current. So they change the charge flow in one direction. So if you have a current in y-axis and the x-axis is the time, you will find out that the directions of the current is only to one direction. But you must have heard about the AC current, which is alternating current. So which means that the charge is not moving in one direction, the charge actually oscillates in time. So the direction of the current change every half period. So do you remember we defined this as one period? Yeah? So now, because the oscillation of the charge, so for the first half of the period, the current is moving in one direction. In the second half, they change the directions. That's the reason we say this is the AC current. The charge alternate in the direction. So actually, most of the device in our daily life is AC current instead of DC current. And the reason is because the energy lost when you try to propagate the high voltage from the power plant to your home device through the AC current is much smaller. So the energy lost during the transmission is much smaller than the DC current. And one of the simple argument is that you can see that the average value of the DC current is just the current itself, but the average of the current of the AC current is very small. And you will come back, you will realize that how important this is about when you try to understand the concept of the energy lost when the current was transmitted. So let's continue. So do you remember in the pictures I show you that you connect the wire to the voltage difference? There is also the resistor in the circuit. So what is the so-called resistor and the electrical resistance? It is a quantity to describe how well a circuit resists the flow of the electric current. So the harder for the electric current to flow, the bigger the resistance of the material it is. So this is the quantity defined measures in the 19th century by ohm. So the unit, the SI unit for the resistor is the ohm. So this is the value you will see also in our previous experiment. And there are several factors will affect the value of the resistance. So first is that the thinner the wires, the bigger the resistance it is. So if you try to compare two wires, one is thinner, one is thicker, but they both have the same length. Probably it is strange to you, but it is true that the thin wires has a bigger resistance, and the thicker one has a smaller electrical resistance. So the first case is they have the same length. Now let's study that. If they have the same thickness, but one is longer and one is shorter, then in that case, the longer wire will offer more electrical resistance. So the longer the resistor it is, the bigger the resistance it has. But they have the same thickness. And also, the materials of the wires affect. So for example, if you have a conductor, for example, like the copper, then this kind of material intrinsically, they have a very low resistance. And that's the reason we use them to make the wires. But the insulator, like the rubber, then the internal resistance is very big due to the molecule structure there. And finally, the temperature will play a role. So in the chapter 6 and 7, we study about the temperature. So the higher the temperature of the material it is, the greater the resistance it will have. So think about that. Resistance is about how easy the electron can passing through this material. But now, because the material has higher temperatures, so the particles, the atoms of the material will move faster than before. So therefore, when the electron try to passing through this material, they have higher chance to interact with the particle in the material. That's the reason when the temperature is higher, the resistance of the material will become bigger. So now you will get to the point, which is the thing we just conduct in the previous lab. Ohm's law. Ohm's law basically connect the three quantities together: the current, the voltage, and resistance. So the current is the movement of the charge. So in order to achieve that, you have to provide a voltage difference. And the wire itself has their own resistance. So the current will flow from the higher voltage to the lower voltage end. And the energy will be given away when they passing through the resistor. So the current in a circuit varies, and it is directly proportional to the voltage difference and inversely proportional to the resistance. So therefore, what it means is that the bigger the current, the bigger the voltage, but the bigger the resistance, the smaller the current. Okay? And if you try to write down this result in terms of the variables, it is basically I equal to V divided by R. And this is the formula we use in the lab. And this is the so-called Ohm's law. So Ohm's law, just give you a reminder, is not always true. It depends on the materials and also depends on the temperatures. But in this class, you can simply assume that if I give you a question asking about the resistance, they should all obey the Ohm's law, unless I give you the particular reminder say they don't. Okay, so feel no worry about this one. So let's have our last conceptual quiz today. So when you double the voltage, you double what? So in order to answer this one, you need to use the Ohm's law. So when you double the voltage, because it is the same materials, so you double the current. Let's read the question carefully again. It is the same circuit. So the same circuit has the same resistance. So now you double the voltage, you double the current. And that is the explanations.